Good evening, everyone. I'm Kamala Gunawardana, highway consultant and a fellow representative of the ISL this year. And I take part in the civil engineering sectional committee activities as well. We are starting the today's event right now, and it is an honor for me to introduce this eminent personality who is commencing this valuable lecture series under the title An Overview of Medium-Rise Building Designs and Constructions. He is a well-known personality who needs no introduction, and is none other than Professor Jayasinghe, Senior Professor of Civil Engineering at the University of Moratuwa. However, I will state very briefly the major expertise areas, and as you all know, he has employed his skills and experiences in structural engineering, computer analysis of structures, and many major designs with researchers, including green technology, for further research developments and dissemination of knowledge, etc. He has also excelled on high-rise building structures with other major structures, designs, and constructions. I think I need to mention that Professor Jayasinghe has extended his contributions to the sustainable built environments in Sri Lanka and overseas, and his practical design and construction of green factories or buildings with the use of many principles as applicable to built environments. Further, I would like to stress the point that as the chairman of Civil Engineering Sectional Committee of ISL, for this session, we are much delighted and expecting many more fruitful programs from him with his expertise areas during this session. Thank you, everyone. Please enjoy this important webinar series actually and get you updated. Without further ado, I invite Professor Jayasinghe to take over. Thank you, sir.
Thank you. Thank you, Mr. Kamala. Can you see the screen?
Yes, we can see.
Yeah. Right. Thank you very much, Engineer Kamala, for that kind introduction. So today we are starting this tall building design series, but before we go into tall buildings, we should know how to design medium-rise buildings. So because of that reason, we'll have a number of lectures on medium-rise buildings.
Sound is bit less. There is coming sound.
So we'll have a series of lectures to enlighten you on the design of medium-rise buildings before we move on to tall buildings. So we are going to have a total of about 40 lectures over the next 40 weeks, and we may have few gaps only. Otherwise, almost all the weeks we are planning to have some kind of activity so that we can keep you occupied and engaged with learning new technology and methodologies that can be used for wealth creation, not only in Sri Lanka but overseas as well. So, Manjula, can you hear me now?
Still, the sound is a little bit low, I think.
How about now?
Now it's almost okay.
Almost okay, right? So basically, I'm a senior professor at Department of Civil Engineering. I graduated in 1987, the beginning of 1987. I finished my PhD December 1991, and you would expect it to be on civil engineering, but it's a mix of civil engineering and artificial intelligence. And we developed the main techniques, and those techniques are used even today to solve complicated problems using AI techniques. So if you want more details, you can type MTR Jayasinghe on web, and you can get a lot of details. And presentation is, today's presentation is ISS Union Sectional Committee. A brief overview of presentation. Now we are going to learn about medium rise buildings. So we should know about tall buildings. Basically, the whole idea is tall buildings, but we are starting with medium rise. So first thing is to see why we need it. So I'm going to tell you a few facts that you may not know, though you have lived in this country a long time. And then we talk about vertical load resistance system, lateral load systems, mathematical models, why we need to know fundamentals very well, and the applications of fundamentals, optimization techniques and risk assessment, the role of Eurocodes for medium rise buildings and so on. But today I'm not going to cover all the topics. So today we'll discuss many things on the board as well, in addition to the presentation. So we might cover only half the presentation. The next lecture we'll cover the remaining part of the presentation. Or sometimes we might need 3 presentations, depending on the amount of material that we are going to cover. And after that, we'll have specific presentations on specific areas, like how to do a model using a computer model, and how to look at the foundations. What are the different types of foundations you can use in normal buildings, and how do you design them? And then how do you design raft foundations, cellular raft foundations? So these are new topics that most of the engineers think that they can handle, but when it comes to real handling it, they struggle a lot. So we can help them in a big way if we cover these topics. So now let's see. Now, what's the size of Sri Lanka? 64,000 square kilometers, very small country. And you can see small countries in the world are also much bigger than Sri Lanka. And when you compare India and Sri Lanka, it's a very small country. Population, 22 million. But out of this 20 million, 2 or 2.5 million live out in other countries. That is one of our strengths as well. Why? We get reasonable amount of dollars coming in. And then you'll ask why we are having a huge dollar crisis now. There are two main reasons. One is we don't have tourism inflow now. Secondly, we have a lot of students studying abroad, and they all need money, dollars. So we are sending out a lot of dollars to outside countries. So it's very useful if we can develop our education system, higher education system, to a much better level, with the participation of government and private sector, so that if we can retain most of these students in Sri Lanka, then we can save a lot. The parents can save a lot of money, and Sri Lanka will have less trouble with dollars. And you might say there are other reasons, like the loans taken at high rates and so on. Those are all there, but there are other contributing factors as well. So now, why we need buildings, tall buildings and medium-rise buildings, and even low-rise apartment buildings? Why we need them? We need those because people like to stay close to their workplaces. They don't like to travel 50, 60 kilometers before they get to the workplace, unless there's a good train service. If there's a train service, 50, 60 kilometers is not a big problem. But if there's no good train service, then 50, 60 kilometers is a long distance. That is a very tiring journey. So people don't like it. And if you look at our train service, our train services are not very good. They are crowded, and we are not having enough trains because we are operating diesel locomotives with vacuum brakes. If you are operating diesel locomotives with air brakes, then at least the gap between two trains can be reduced. So with the available infrastructure, we cannot develop the train services very well. Because of that reason, we'll have to go for apartment buildings in the future. So there will be a huge demand for low-rise apartments, medium-rise apartments, and high-rise apartments. or tall buildings. So out of these, medium and tall buildings would be at a great. And you have to see why we have a great attraction with. We have to see why we have a great attraction with medium rise and taller buildings. Can someone give an answer? The answer is, when you come closer to the cities, land prices go up. So if you go for low-rise buildings, then you are dividing the number, dividing the price of the apartment, price of the land by only 5 apartments. A tall building, you go for a very tall building, then you are dividing the price of the land by a large number of apartments. Then the contribution to the price of the apartment from the land will be low. So to keep the contribution from the land price per apartment, we have to consider medium rise buildings and taller buildings. So that's the philosophy. That is the philosophy. So because of that reason, you will see that in future we will get more and more apartment buildings of medium rise and tall. And the moment you move closer to the city center, the land prices can easily reach something like 10 million rupees per perch or even 15 million. And certain locations in Colombo, the land prices are 25 million rupees per perch. So if you have 50 floors, then the contribution from the contribution of the land price to the apartment price will come down to 0.5 million rupees per apartment, per perch. A 1,000 square foot apartment, then you'll find the contribution from the land is only 2 million, which is very attractive. So that's why the apartments are very attractive. The attraction comes not only from the fact that they are apartments and they can be compact, but the attraction comes because so then I told you that we have a significant number of people living abroad. And what will happen? They reach retirement, they will find that willingly are not that easy. Because winters, when you are old, you are 65 years, 70 years old, you'll find that winters are not that easy. Then you will think, okay, if we can have a holiday home in another country where the tropical climatic conditions prevail, then you might consider that option. So in future, we can create a market like this, where people will spend 5 to 6 months in Sri Lanka during the cold times, and during the summer times in those countries, they go back to their own countries where they have lived so long, rather than staying in Sri Lanka. Then we need apartment management companies who will actually rent the apartments to the people from the other hemisphere. Because we know when we have winters starting in December, in the northern hemisphere, we have a summer in the southern hemisphere. So if you have an apartment in Sri Lanka at a good place, close to the highway entrances, so that people can travel easily, like Maharagama, Kottava, Homagam area, then there's a chance that these people might consider buying those apartments, provided the apartments are priced reasonably. But if you look at the prices of apartments in Colombo today, they are not reasonably priced. They are highly priced. Like, you get apartments sold at 60 to 80 million rupees. And some of the apartments in Colombo can even go beyond 100 million rupees. So those might not be attractive. So we need to come up with very cost-effective solutions. And we are going to discuss some of those cost-effective solutions in the latter part of the lecture series. So we have to bring the cost. In the present rate, the apartment cost vary between 12,000 rupees per square foot to 15,000 rupees per square foot. That is the cost. But if we can bring that down to about 7,000 to 9,000 rupees per square foot, then we can make a huge advantage, because the sale price of the apartment can be kept less than 20 million rupees, which would be attractive, considering the fact many people doing reasonably good jobs can get loans where the loan repayment might be about 80 to 100,000 rupees a month. So when you consider the combined income of a household, that type of loan repayments can be attractive. So you might find that, 15 to 20 million range, apartments can be easily sold in Colombo. Apartments can be easily sold in Colombo. Whereas if you are going for 25 to 35 million range, then you have to rely on foreign buyers to buy. Foreign buyers means the people who lived in Sri Lanka, who migrated and worked abroad. They are willing to come back due to some reason, and that type of people will find the highly priced apartments attractive, because their money has a high value when you convert from dollars to rupees. So the other sector that we can actually develop is the hospital sector or the medical facilities, so that the people of old age will consider that Sri Lanka is a good destination, because you can see a doctor very easily by paying 2,000 rupees or 2,500 rupees and easily making an appointment. You can go and see a good doctor very fast. So that type of facilities will be very attractive to people who are considering retirement. So those are all different options that will make apartment a good business in Sri Lanka. So as engineers, we should be ready to come up with cost-effective solutions so that these apartment buildings will be very attractive for the buyers. So that's what we are going to discuss in this particular lecture series. And then we have to also know that Sri Lanka is a very good country when it comes to carbon footprint. And the carbon footprint of USA is about 70 tons. Canada is about 14 tons. Germany, it's about 9 tons. UK, it's about 7.6 tons because they use nuclear as well. For France, 5 tons. You can see France is an industrialized country, but most of the electricity is generated by using nuclear. So because of that, they have low carbon footprint. South Korea, 12 tons. China, 8 tons. But if you consider the 8 tons per person per year multiplied by the population of China, China is the biggest polluter. Malaysia, 8 tons. Thailand, 4.5 tons. Then you might ask, what is Sri Lanka? Sri Lanka is less than 1 ton because we have a strong agriculture sector. We have a weak industrial sector. Except even when you have industries, it's like garments and so on. Not energy intensive industries. Whereas if you consider countries like Malaysia and Thailand, they have car manufacturing industries, heavy industries. So their carbon footprint should be more. And we use renewables, we promote renewables. And Sri Lanka is a good country for renewables like solar. And so at least on paper, government is interested in improving the forest cover, but there can be so many voluntary programs, and even ISL can consider having one event per year where we encourage planting of trees, or we sponsor spreading of seeds to improve the forest cover. And that is a little costly operation, but if we all get together, contribute 100 rupees or 200 rupees per year, we might be able to fund a campaign where in one of the days, just before the rainy season, we can spread seeds of various valuable trees in the forests having low density forest cover. Some of our forest reserves used to be very attractive paddy fields, and due to various activities of the people, some places you find that the forest cover has diminished, and we can actually sponsor a program to plant trees so that these patches can be removed from the forest, so that the total forest cover can be improved. Then we also have problems, and one of the biggest problems is sand. Sand is very expensive, and one kilogram of sand is 5 rupees, 1 kilogram of cement is 20 rupees. So there's a big disparity. Cement is a properly manufactured item costing only 20 rupees with artificially low prices, but actual price should be about 30 rupees per kilo. But government tried its best to keep it down and failed. And in doing so, it actually affected the economy and supply chain as well. So basically, wrong policies like price controls can actually bring huge disparities and shortages. So we have to be mindful about that. And we are having a sand short supply. Cement is also little problem. Steel is also little problem. And the biggest problem is steel is very expensive. Steel is very expensive. So it's the steel has gone up in price much more than the price increase in concrete. Because of that reason, you will find that, rather than using normal reinforced concrete, it might be worthwhile to consider precast systems. Out of piece concrete, like the nerd system, can be very pretty effective these days. So again, we have to look at those aspects. And not only that, if you look at the history, even 1970 to 77, we had an era where the resources were scarce. And those days we used wattle and daub construction in a big way. And when you look at wattle and daub construction, you might laugh at me, saying that is going to the ancient age. But if you go to the Temple of Tooth Relic in Kandy and ask what is the material they use for constructing the walls, then you will find that it's wattle and daub, or what we call varichi in Sinhala. So it's wattle and daub or varichi, and that's what you find in the Temple of Tooth Relic in Kandy. So that building has lasted more than 200 years. Now it's close to 300 years or more. It's about 300 years old. And if such a building can last so long, why not today? Today we have better methods like boron treatment for timber. So if we make the timber framework out of boron treated timber and then cover it with mud, then you'll find that kind of buildings can easily last 100 years. So basically, we are planning a hotel project, and in hotel projects, we like things to be different. And we are planning to use 3-story load-bearing water and dope construction for these hotels. So we are doing some experiments now, thinking and improving and so on. So a lot of brainstorming is going on, but we are determined to use soil for construction. It can be cement stabilized rammed earth, it can be cement stabilized blocks, or it can be water and dope. But whatever it is, we'll use modern technology and make sure walls are perfectly level, walls are perfectly vertical, and there are lightweight subsystems and so on. So we are going to do something like that. And then we have waste materials like expanded polystyrene, and you can make use of such materials as building materials to make lightweight concrete. And there's one panel that is manufactured in a factory at Jayasinghe, and the almost 100% of the regiform that is used to manufacture the panel are all waste products. So basically, we use waste material and then convert those to useful building materials. So there's a lot of scope for all of you to master all these different techniques. So before we think about medium-rise buildings, we'll just have a look at some of the large buildings in Sri Lanka. And some of these buildings are in clusters. So we have so many different clusters in Sri Lanka. So if you one cluster is golf face green cluster. And in addition to, in front of that, we are going to get a Port City cluster. Then you can have Havelock City. You get another cluster of building. And then when you go to Rajagiri area, you get so many tall buildings again, apartment buildings constructed by Maga Engineering. So likewise, all over Sri Lanka, not all over Colombo, there are clusters. And these clusters are going to grow more and more. And where do you expect the next cluster? Inside, within Colombo, just outside Colombo. And my prediction is we might get a cluster close to Homagam. And you might ask why. The reason is from Homagam, you can come to Colombo using trains. And for that, we have to make sure we have tidal flow in the Kalaniya railway line. So what do you mean by tidal flow? Tidal flow means every 10 minutes, we'll have a train coming to Colombo on this line, a large, long trains. But in the morning, all the trains will be from Padukka to Colombo. Until 9 o'clock or 10 o'clock, all the trains will be, every 10 minutes, you will get a train coming from Padukka to Colombo, but only in one direction. And then during the evening, after 4 o'clock until 8 o'clock, all the trains will be from Colombo Fort to Paduk. So one after the other, the trains should go. For that, we have to make sure we manufacture trains in Sri Lanka. Then you'll ask, how? Can we manufacture trains in Sri Lanka? The answer is yes. And you'd have seen on YouTube, there's a program to repair railway carriages, and the cost of repairing a railway carriage is only 10 to 13 million rupees. Whereas the replacement cost can vary between 65 to 85 million rupees. So which is better? Bringing the railway carriages to Sri Lanka from India and China, or making the railway carriages in Sri Lanka? You can clearly see making the railway carriages in Sri Lanka can be a very attractive solution. So if you have trains, good train service, then we can live close to Homagam because we can easily come to Colombo. But because Homagam is close to the highway entrance, we can travel to any part of Sri Lanka because we might get the Central Highway Section 2 open shortly from Meerigama to Kurunegala, which takes on 20 minutes. And the first phase is progressing well, which means
from Colombo to Kurunegala, from Colombo to Kurunegala will take less than 1 hour. Less than 1 hour. So if you can travel, if you live in Homagama, you can go to Katargama in 2.5 hours. You can go to Anuradhapura in 2.5 hours, which means the Homagama, the areas around Homagama will become a hub again for tall buildings in future. And for those things to happen, we must make sure our engineers know how to do proper designs. So first we look at some of these designs, and you can see this Altea, and this is about 3 years ago when they were constructing, and one tower should be leaning against the other, but it's not happening. Here you can see this tower is on its own. So up to 43 floors, one tower will be on its own, and that is the steel tower. And this is the concrete tower. This tower is out of concrete, and this small the inclined tower or leaning tower is out of steel, because steel has less weight, and but because of diagrid it could give adequate. And you can see this model of Altea that I made in 2013. Or 2012 also I made a model, and then 2012 I made these models. And you can see in the model you get the superstructure above the transfer plate. Here you get a transfer plate, then the superstructure below the transfer plate, and then the foundation, the piles, all model, and a certain stiffness has been allocated to represent the bedrock stiffness. And the stiffness of the bedrock is very high, and we should learn how to model, how to give the spring stiffness to a model like this. So that's a part of theory that I will teach in due course. And then we should know how to model transfer plates. So that's another story that we are going to cover. Likewise, we have so many different things to cover. And the design engineer is Predrag Error. And you can see his name is Error. He is from Yugoslavia. And then we have, I certified the building. I checked the building, made the model, and after checking all that, I certified the building. Because I have this high-rise building license, so I certified the building. And we are planning to make sure that, those who are not having postgraduate qualifications can make use of this particular series of lectures to improve the number of stories that they can certify. So if you are not having any extra certification after attending this course and after attending to all the assignments, and if you are happy that you have done it well, we are trying to get the permission of the council, the current council, to give you a certificate indicating that you attended the course throughout and then did all the assignments which are index number. We assign an index number to each of you, and then you will find that it's all index number based, because first you will register you, and there will be a process. Only thing is, our president is not well, so because of that reason we could not get all the permissions last council. So within this council, coming council or the next one, we'll get all the permissions. After that, we'll announce the benefits you can get by following this particular course when it comes to obtaining the taller building license. So if you are in four floor category, that is no license at all, then you can make use of this particular course and the knowledge that you gain to show that you can manage up to 8 floors. If you are already in the 8th floor category and if you have attended this course, then you can show that you are now eligible for 12 stories, provided that you can show some evidence that you are currently engaged in a 12-story building. Likewise, you can go up and up. But if you want to get the tall building license, which is exceeding 20 floors, we strongly recommend you to follow an MSc in structural engineering, because you need broad knowledge if you are going for if you are going to design buildings having more than 20 floors. So we strongly recommend you to go for the you can follow a structural engineering MSc, and structural engineering MScs are offered by Moratuwa, Ruhuna, Open University, and Peradeniya. So all the universities, all the major universities are offering, all the major engineering faculties are offering MSc in structural engineering. So if you are interested in going up to tall building license, we strongly recommend you to go for attend a proper MSc course. Don't stop at the PG diploma, or go up to MSc. And then you'll ask, how I got involved. Mr. Bimal Fernando is a fairly senior design engineer who is working in the industry. After a lot of experience in Mahavali and then Holcim and all that, now he's a freelance consultant. And he's the one who asked me whether I can get involved in this project. And I said, okay. And I did not even bother to take a very high fee, because I just wanted to help my friends. So, but you can see the fact that we can model a building like that gives ample evidence that we know the subject well. Now, this is Clear Point, which is a very special building at Rajagiriya. And you can see the speciality of this building is, no columns at the edges. These are all open spaces, open balconies. Open balconies. It's a very nice building. And some of these balconies are made possible by having beams like these beams. And these beams are not reinforced concrete, they are pre-stressed concrete. These beams are not reinforced concrete, they are pre-stressed concrete. Then you'll ask, who designed the building? Mr. Nuwan Senaka Vanikaratna did the engineer. Nuwan Senaka Vanikaratna did the design. He's one of the best in Sri Lanka for structural design of buildings, and he can design bridges as well. He has designed at least 2 bridges. One is having a length of 75 meters. The other one is having a length of 125 meters. So if you have designed 2 large bridges like that, then you know bridge design as well. And I taught him bridge design. And because we had to, Maga Engineering had to come up with 2 alternative designs for 2 bridges on A4 highway beyond Panam. So we did those designs over a short period, and then Maga Engineering completed the construction of those bridges in less than 4 months. So it was a very rapidly constructed, we can say rapidly constructed long span bridges in Sri Lanka. So those 2 projects. And he's very good in design, and the tallest building he has designed has 77 floors. And that will be the tallest building shortly in Sri Lanka. It's a twin tower building. And it's called the Address 606. And if you are been to Bambalapitiya area, a little beyond Bambalapitiya, on the left hand side, you get something called Marina Shopping Complex, Merino Shopping Complex by Damro. And next, before that building, and you're coming towards from Bambalapitiya towards Colombo, just before that building, you get a tall building, and that's called Address 606. And that building is now the one tower is almost over. They are delaying the other tower a little bit until the market improves a little more. So basically, this tower will be taller than, once completed, it will be taller than Altea. Altea has 68 or 69 floors. Some say 69, some say 68, because there are some basements. We really don't know how they started counting. So basically, Altea has 5 basements. and so the design had to be carefully handled. And those aspects, how to design the basements, and what are the geotechnical modeling you can do, all that I have already spoken to Dr. Nalin De Silva, and he agreed to conduct a lecture series on that as well. And in addition to that, I have talked to engineer Rohit Silva, living in Sydney, Australia. And he's a very good design engineer. He passed out in 1991, and he is a very bright engineer. So he agreed to do about 5-6 lectures on design of bridges that we are planning to have it on Wednesday. And he's also a tunneling expert, so he will conduct few lectures on tunneling as well. So we'll facilitate from this end, and he will speak from Sydney, Australia, so we can be thankful to the 4G technology, and we hope that it will improve even further with 5G. So basically, you can see a lot of innovative ideas can go into a building, and when we are willing to think outside the box, we can always come up with these new ideas and then try to implement. Then you'll ask, I can ask a question. Now, when the architect asks for 4.5 meter cantilevers, there's one good way of handling it. You say, it's not possible. But it's not a good way of handling engineering. If you are a civil engineer, structural engineer, the building belongs to architect. So you have to look after the architect. You have to work with the architect, because architect is the one who created the building. Then only the opportunity will be available for all the other engineers, like the structural engineers, building service engineers, electrical engineers, telecom engineers. All of them can come in only if the architect develops the project with the client. So because of that, we have to respect the architect and make sure that we look after him, because he's all alone, and engineers are the people who are expected to look after the architect and then work together so that the wealth can be distributed among all the participants. And one of the good things that you have to keep in mind is, whatever the architect asks, see whether you can design it. It might look like a mad idea, but once you design, it might be a marvelous idea. So always don't think about reinforced concrete as the only material that is available. Reinforced concrete is one of the materials available. We can have pre-stressed concrete used in buildings extensively. And then we can also have many other materials like lightweight panels. And you might ask one day, in a hotel building, multi-story hotel building, why not waterland dome? Because I want it to look attractive for the tourists. So when you are looking at the options and helping the architect, make sure we look at all kinds of materials, and also if there's an opportunity, develop the materials so that you can give good solutions to the architect. And this is Sky Garden, a very nice building in Rajagiri. And you can see the building has turned by 45 degrees at the transfer plate level. And this Fairmount, this is the first tall building that Maga constructed on their own. They have constructed buildings for others, but this is the first building they constructed as part of their own project. So these all Sky Garden, and this Crescat Monarch. And again, I can show the model of Crescat Monarch. And this is the model that I checked in 2006 or 2007. I think 2006, late 2006 or early 2007. So they wanted a design review done. And I was approached, so I made a SAP 2000 model of the whole building. And you can see the actual building and the model looks similar. Now I can ask a question. The question is, how do you design these buildings with confidence? Some engineers say, if I can satisfy Eurocode, I'm happy. And if you have that attitude, will you ever be a good engineer? The answer is no. Never have that attitude. I have satisfied the code requirements, so I'm okay. Don't say that. You have to develop a thorough understanding of how the structures behave and using fundamentals and theories. And for this, you have to make sure you work very closely with other professionals like geotechnical engineers and construction engineers. So the answer is BSEN can never give confidence, and BSEN can tell the way forward. And what is BSEN? That is the Eurocode. That is the Eurocode. The BSEN is the English version of the Eurocode. And you can use the national annexures. So if you don't have a national annexure by SLS, the procedure is simple. Simply use the national annexure for UK, because you can get reasonably good comparison that comes because they are also having fairly warm summers. The summertime temperatures can go up to about 30 degrees. So anything applicable to them can be applicable to us, because ours also, because being an island, our average temperatures also remain in that range, So because of that reason, you can always make use of the national annexure of UK if you don't have a properly completed national annexure. So adoption of Eurocodes is strongly recommended. And if you are not familiar with Eurocodes, start learning Eurocodes. And the easiest way to learn Eurocode is by using the book by Mosley and Bungie. The 7th edition by Mosley and Bungie. Start learning the Eurocodes, because easiest thing is to learn the Eurocode by using concrete. And then you can, if you are not happy, you can't understand some of those things, then get a copy of the same book, Mosley and Bungie, Reinforced Concrete Design to BS 8110. That is the earlier code most of you would be familiar with. And then learn that, and then come to version 7, which is based on Eurocode. Then you will find that you can now understand the provisions given in Eurocode. So that way you can learn how to use Eurocodes. If you try to just turn the pages of a Eurocode, you'll find they are very complicated, almost impossible to keep a track. But there's a simple method that I have developed. So as we move forward, I will let you know how this Eurocode is organized. And the next important thing is, we have to start testing materials for Eurocodes. Then only, we can develop our industry. So let's look at a simple example. So we know when a beam is continuous or simply supported, both occasions, the support regions are subjected to heavy shear. In the spans, it can be subjected to high bending moments. There can be high bending moments over the supports, but when it comes to shear, it's very high shear close to support. And then if you look at the Eurocode, it says, you can provide the reinforcement, the effective depth away from the face of the column. Then you look at the face of the column and the region between d distance away, and that region also the code says provide the same reinforcement. But when you look at earthquake design, now you will find for earthquake design, the plastic hinges can form very close to the column. Because of that reason, the code provision at one place may not be applicable the moment you consider an earthquake resistant design. So because of that reason, you should not look at one code and say, I'm okay, I know everything. Always look at, there are about 35 Euro codes, and some of them may not be applicable at all. But otherwise, see, things like the masonry code and timber code, you might not use in a tall building straight away. So you don't have to bring everything together, but make sure you practice using these codes, using textbooks like Musi and Banji or McGinley, and if you can't understand the latest Euro codes, try and understand the British codes with the principle, with the theory. Then you can use books by Allen, Musi and Banji, and McGinley, and so on. Learn the British code and then see how it compares with the Euro code, because Euro code and British code cannot have so many different things because we are dealing with the same material. Material is concrete. So whether the concrete is made before Euro code or after Euro code, concrete properties will be the same. So because of that reason, we have to make sure we learn these codes wholeheartedly and try and become masters of them, because we are now working with CEDA and NBRO, National Research Organization, Construction Industry Development Authority, to ensure that Euro codes will be mandatory for Sri Lanka road nations now, but in the British, but they will vanish in no time. So the advice is try and spend some time learning Euro codes, because the opportunities in Africa and also Port City is a 40-year project. Just keep it in mind. So if you learn something new, you might be able to convert it to a wealth creation activity. So just think about it. So how do you deal with all these different complicated codes? So what you do is you go through the theories, go through textbooks, and develop your own rules. So we call them rules of thumb, rules of thumb. So you develop rules of thumb, and so a complicated procedure given in the Euro code, you might have 3 or 4 rules. So at the preliminary design stage, you can make use of these rules very well. Rules very well. So this is one of the tasks. So because we are going to share the presentation, I will not go through the slide fully, but what I generally do is, when I'm selecting the general arrangement drawings, I will make an assessment of the shear forces. And once I make an assessment of the shear forces, I can calculate the shear stresses approximately with reasonable accuracy, like 95% accuracy. And then I will try and keep the shear stresses somewhere around 1.2 to 1.5 newtons per millimeter square, the maximum shear stress. And in doing so, we are actually selecting a reasonable cross section for the beam. Otherwise, if you select a section which is too small, then you will find you need a lot of shear reinforcement. When you need a lot of shear reinforcement, one thing is, it's difficult to fix it. Secondly, difficult to pour concrete, and you can end up with honeycombs. So because of that reason, we like to have a minimum spacing like 75 millimeters when it comes to shear links. And anyway, in most of the designs, I use something like 75 millimeters close to the beam column junction. So that beam, if the beam plastic hinge, there will be plenty of steel reinforcement in the form of shear links to distribute the cracks so that the cracks will not, and also when the stress, there will be sufficient confinement to concrete so that the concrete will not crush. So there are so many benefits you can gain by going for earthquake based designs. The extra cost will be only about 2 to 4%, 2% of the structural cost, or 2% of the overall cost, or 4% of the structural cost. So basically, it's not too much money. It's only a little bit of money extra. So to make the building totally free, totally safe in case of earthquakes. So it's not difficult. So you must know it's another rule of thumb. Another rule is, if you adopt earthquake detail, somebody asks, how about earthquake detailing? You say yes, it's possible, but there will be a cost penalty of something like 2%. Then the client can make a proper decision, because client is the one who finds money. So we have to always list problems out. And then if then you might adopt a different philosophy. Now, what is that philosophy? You might think, okay, because we are using Eurocode, we can use high strength materials. So if we can tighten the site superposition to the level that we use 50 megapascal concrete instead of using 30 megapascal concrete, we can make many things small, many sections smaller. And that way we can save money. On the other hand, rather than using pre-stressed concrete, reinforced concrete, because steel is so, you might consider using pre-stressed. So the list can go on and on and on. But whenever you get a building, don't think it has to be reinforced concrete. No, it can be out of any material, especially the flow systems. Especially the flow systems. So then you'll ask, Sri Lanka, we did not have a magnitude earthquakes. The answer is simple. The answer is simple. We are within a plate, but one of the biggest earthquakes have occurred within a plate, and that is in the Washington state, not in Washington, Washington state. The magnitude was 8.9 on Richter scale. So, which means, though we are within a plate, we should not consider that we are free of earthquakes. And then, if you look at the historical records, in 1640, there's a huge earthquake in south west of Colombo, and of gases released. It looks like it's a fault that has slipped and created the earthquake, and 200 people died, 2,000 houses were destroyed, part of Colombo. There are enough graphic evidence of this particular incident.
So some comments received that the sound is not that clear. So
Is it clear now?
yeah, now but echo some kind of reverberation.
Yeah. Now I have to turn off the other one. Just one more. Manjula, can you hear me now?
Yes, but
Yes.
still bit echo is.
Yeah, echo is because I'm having this phone. I will remove the phone. Now can you hear me?
Yeah, can manage.
Yeah, can manage. Yes. So basically, today we'll look at the overview, but from next day onwards we'll I will show you the concepts. So today will be just a brief overview of different methods and techniques that we should be following. And so I will skip this particular slide because it talks about the little more details about the way that we can have the lateral load resisting system. The lateral load resisting system of a normal small building can be the frame itself. But when it comes to the medium rise buildings, we can make use of shear walls, because if the building is having more than 5 floors, we need a lift shaft. So the walls around the lift shaft can be converted to concrete if we need lateral stability. But it does not mean in small buildings like less than 10 floors, all the lift shafts should be out of concrete. No, it's not. We can have 1 or 2 lift shafts out of concrete, the rest can be out of masonry. The reason is a concrete wall is much more expensive than a column. The wall is long, so don't use concrete walls unnecessary. If it is a say 15-20 story building, no harm in having reasonable number of strong walls. But if it is a 5 or 6 story building, there's no need to have a concrete core, provided that you have done the design as for a unbraced frame. So we skip this particular slide, but I'll be using this particular slide again, and then we look at some of the special features that we have to look into in planning the buildings in Colombo, because one of the UDA regulation is all the office buildings, all the apartment buildings must have their own car park. Without a car park, you can't use a building in Sri Lanka. It's a very strict regulation. So what happens when you go for car parking? The size will be 4.8 meters by 2.4 meters for each car parking slot. So which means you have to now consider a grid of about 7.6 meters, so that 3 cars can be parked in between 2 columns. And it's not good to have grids of 5 meters in a medium rise building, because the loads are high and you can get various problems in doing the foundations. It's not good. So generally, if it is a medium rise building, we go for a grid of at least 6 meters, sometimes preferably about 7 or 8 meters. Then you'll ask, if the grid is 7 or 8 meters, what will happen to the slab design? Slab is going to be too thick. No, we are not going to make the slab too thick. We are going to have a secondary beam system so that the slab thickness can be reduced, reinforcement can be minimized, and the beam will look after the slab. Beam will look after the slab. So you can see in Sri Lanka, when you are planning a building, if you are going to continue the same system of columns without a transfer flow, then you will find you need fairly large spans. On the other hand, we can say we are going to have one column system below the transfer plate where we are getting car parks, and we are going to have another grid above the car park, which means we need a transfer plate or a transfer beams. And small buildings, we always go with transfer beams. We don't use plates because plates are very expensive, difficult to cast, and so many problems. So because of that, we are not very fond of transfer plates. We like transfer beams, and or else we like cellular transfer plates where we have a bottom slab, the ribs, the beams, and then a top slab. Within that, it's hollow. So that's another attractive option. Easier to cast as well, because we can cast the bottom slab first with starter bars for beams, and then we cast beams and the top slab together, and we sacrifice the formwork that we used to cast the voids. So that formwork will be there forever, and we don't see it, so we know we are not worried. And you can use old timber to make the formwork. So basically, when you are looking at this type of scenario, you see you are going to get fairly long spans, but the long span does not mean we are going to get a deeper beam. So if you get an 8-meter span, still you like the beam size to be 600 millimeters of depth. What is the main advantage of having a shallow beam? The advantage does not come with flexure, but it comes with earthquake resistance. In case of an earthquake, if you have a large beam and a small column, where the plastic hinge occurs in the column. Is it a good feature or a bad feature? It's a very bad feature, because if the column collapses, whole thing collapses. So because of that reason, we like beams to be shallow, and we don't like beams to be deeper than 600 millimeters. So how do you manage 8-meter span with 600 millimeter beam? The answer is very simple. Don't go for a 300 millimeter wide beam, go for a 400 or 450 millimeter wide beam. Go for a 400 or 450 wide beam, then automatically you will find the beam is okay. 600 millimeters is okay. So you have to train your mind to look into the fundamentals like that. Because we know flexure, to improve the flexural capacity, we need depth. But to improve the shear capacity, we need the area. So what we do is increasing the area to improve the flexural capacity is not very efficient. But because we are having a restriction on the height of the beam to about 600 millimeters, to ensure that plastic hinges will always occur within the beam, not in the column, it's worth having a wide beam. It's worth having a wide beam. So you can see, we are not just thinking about tall buildings or medium-rise buildings. We are thinking about philosophy. And that kind of understanding is very important for structural engineers. And if you know how to use the code, it will never make you a good engineer. But if you dig into the philosophy and start making your own rules, then you'll find suddenly you have become a good engineer, or at least you are becoming a good engineer. that whom will be appreciated by your clients, appreciated by your colleagues. Because when you ask a question, your answer is not a traditional answer. Your answer is something innovative. And that's the way we should tackle the real day-to-day designs. Not merely following the codes, but thinking, what can we do new every day? For that, you have to be thorough with materials, the methods, codes, and then you can start developing your own set of simple rules. And for example, when I do a design, I never look at codes. I always have a set of rules in my mind, and I always use those rules. So next day, on using the board, I'll show you how to do a general arrangement for a medium-rise building. Say, I'll show you how to tackle a building having less than 10 floors and another building having something like 15 to 20 floors. So today we don't have time to do all that, but today I just wanted to highlight that what you are going to learn in the next few months. So you will learn things like rough foundations and how to model a rough foundation on sandy soil, how to model a rough foundation on clay soil. The models are totally different. And you will learn all these different ways of interpreting the parameters and working out the elastic moduli and so on for soils. That will allow you to do mathematical models for structures. So on one side, we are going to have a very strong foundation course, which will be the modeling part. I will show you how to do the modeling part, but Dr. Nalin Silva will come and teach you the real geotechnical part, and he will also take you to more advanced designs, ultimate limit state based designs for foundations. Because at the moment we are doing serviceable limit state based designs for foundations, but he will show you how to use ultimate load based, ultimate analysis based designs for geotechnical engineering, which is allowed in the modern Euro codes. So then I can show you some of these transfer plates, arrangements, and this is a sky garden building, and you can see the transfer plate is actually facilitating the turning of the building by 45 degrees. So we'll discuss all these things. Mr. Manjula, what do you think? The time is about 6:30. Shall we take some questions and wind up the lecture? Because we have to start another meeting at 7 o'clock.
Yes, we need to get questions, and we have our sectional committee meeting at 7. So
yeah, that's right.
we have to get.
Yeah, because I have shown you a new.
We'll wind up at 6:45, sir. Then
6:45. Yeah. Okay. So basically, what I want to highlight with the overview is we have to think differently, and never think that just because you have done a calculation according to a code of practice, you are safe. You are not safe. And you have heard about this building collapse in Miami, where nearly 100 people died. And you will ask, why that particular building collapsed? And some immediate thinking is, okay, sometimes it could be the foundation collapse. But the real reason is different. The real reason is, it is a failure of a key element. Because key element is the elements that are actually holding the structure together, and failure of any of those structural elements can mean the total collapse of the structure. And one of the key elements that could have easily collapsed in that particular building problem was the transfer plate. Why? Because it's so easy to under-design the transfer plate, or you can have a transfer plate where you have the same factor of safety as any other beam in the structure, which is wrong. Why? Transfer plate is so important So transfer beams are so important. If you have the same factor of safety as any other beam, then you are doing a big mistake. So this is called risk assessment. For every element, when you are designing, you will not look at the bending moment. You can see, you will look at whether this bending moment change over the lifespan of the building. If the bending moment can change, then you have to include that change in the bending moment in your design. For example, when you design the building, you will model the building, the foundation, then car park levels, then transfer plate, and then the building above the transfer plate. And it looks like one building, like this, one building. But when you consider the construction of the building, construction did not happen this way. Construction happened floor by floor, floor by floor. So what will happen? What happens is this transfer plate will have higher bending moments and higher deflections because you are doing the construction stage by stage. And the bending moment due to dead loads can be as high as 30% of the original bending moments. So the bending moment will not be 100, it will be 130 or 135. Shear forces increase by about 10% when you are doing stage construction. And the modern software has capacity to do this analysis, although it takes little time. So if you are not going to do any calculation for this particular aspect, how you are going to deal with it? Again, you will have a simple rule. What is the simple rule? Calculate the bending moment on the transfer plate from a model like this. Then calculate the dead load bending moment, increase the dead load bending moment by 50%. So if you increase the dead load bending moment by 50%, then you keep on adding all the bending moments into live loads, finishers, services, all will be added. Then you will find the final bending moment has increased by about 15% or 20%. And you will do the design for that particular bending moment. And then you can again be little more generous by adding few more reinforcement. So with all this, what have you done? You have increased the factor of safety in this particular member to about 3. Instead of 2, now the factor of safety is about 3. What are the chances of such a member developing cracks and undergoing corrosion? You will say the chances are much lower. Why? Stresses are much lower. If the stresses are lower, the chances for cracking will be low. So basically, you can see designing a building does not mean getting numbers from a software and then finding the reinforcement. Again, you have to look at how the building is going to behave short term and long term. Short term and long term. And then you have to adjust the numbers you get from the computer software and then do the design. So that's why we don't like doing the design by using the software. Because if you look at MIDAS, in case of MIDAS, all the students at Boroto University, they are given a MIDAS license, full license, and the license consists of the license of MIDAS GEN, which is for buildings, MIDAS Civil for highways and all the other types of structures, MIDAS GTX for advanced geotechnical modeling like basement modeling, that you use Plaxis 3D or 2D, you can do all that with MIDAS GTX, MIDAS SoilWorks for slope stability analysis, and MIDAS NFX for finite element modeling, and MIDAS NFX CFD for computational fluid dynamics modeling, and MIDAS FEA for advanced concrete fracture mechanics, and also the design of bonds. In biomedical engineering, all can be done by using MIDAS. And all the students in our faculty of engineering, including the postgraduate students, are eligible for web-based license. And we expect that, this will happen in other faculties as well. So that Faculty of Engineering students at Peradeniya, Ruhuna, Jayasinghe, Colombo, all will have this kind of facility so that they can do advanced modeling and learn the real modeling when they are undergraduates, because they have plenty of free time when they are undergraduates, especially at the beginning of semesters. So they can learn and become very good in modeling. The reason is we should start thinking of job market not within Sri Lanka but outside Sri Lanka. For that, you have to be good designers, and good designers should be good modelers. So you have to master computer modeling, and we'll again teach you how to do various computer modeling and various techniques by using SAP 2000, ETABS, and then we can also have few sessions on MIDAS. And I will get Engineer One Senaka showing you some of the tricks in MIDAS. And also we have Engineer Anurad Silva. He is also very good in MIDAS. So I'll get some of those engineers who are actually using MIDAS to give you one or two demonstrations as the lecture series progresses. So basically, we have good software like MIDAS, ETABS, SAP 2000, and don't say I am familiar only with one software. Always try to be familiar with at least two software, so that if you want, you can do some kind of comparison of your model answers. So basically, with that, I like to wind up today. And if I summarize, I said that, we'll talk about medium rise buildings first before we go into tall buildings. The reason is we have a lot of things to learn about structural design than what you have learned at universities. Unless you have been an engineer working at a design office, most of you may not be very familiar with the difference between the things that you learn at the university and the real structurals. So my idea is to show you where things can go wrong so that you will be cautious, and also to show you different approaches that are available where we go beyond the course of practice. And also I wanted to highlight why, if you are not familiar with Eurocodes, why becoming familiar with Eurocodes will be so important for a bright future. The future is Eurocodes in our region. So Malaysia is already adopting, Singapore is adopting, Sri Lanka can adopt Eurocodes. India will not adopt, but they will be including the various clauses from Eurocodes in their own codes, because their own codes will be a mix of good codes. So you can see that all over the world they are moving for better codes like Eurocodes. That will give you a lot of options, and because you have a lot of options, you are not guided well, you can do experiments and come up with new methods by thinking outside the box. So we know some engineers used to say, if I follow the code, I'm safe. But we don't want that kind of engineers. We like to see engineers who are saying, I know the code, but I know how to sketch it even a little more. And for that, I have my own set of rules. And by using those rules, I can handle any complicated situation very fast. And after I come up with a preliminary solution based on my rapid calculations, I'll do a complete design again by doing proper modeling and also using proper material properties. Everything will be proper the second time you do it. But initially, at the preliminary design stage, you have to come up with good solutions. And to come up with good solutions, you must become very familiar with codes and then see how you can develop your own. So with that, shall we wind up, Manjula?
Yes, now 6:47. We'll wind up, and we will
We
have
can
the
take few
next.
questions. How about the chat is
Shall
sent?
we say about our next presentation that will be on next
Oh,
Tuesday?
yes, of course. Tuesday again, because we have reserved Tuesday for buildings. So I will continue. Next Tuesday I will do the lecture on the board, where I take some examples and highlight important issues of how to handle the preliminary stage of the design. And then Thursday, you are going to get another lecture. These days, we are talking a lot about blasts created by gas cylinders and so on. But blast is a big problem can become a big problem, especially the situation in a country is not peaceful. So we have a blast expert, as one of our staff members at the Department of Civil Engineering, University of Moratuwa, Dr. Lakshita Fernando, who graduated in 2015 and finished his PhD last year. And we took him to our staff because he completed all his degrees in less than 6 years of passing out. There's a rule which says, to become a senior lecturer, you have to have 6 years. He did not have 6 years. Because of that, he's working as a lecturer. But he's a very good researcher, and he can present well. He's very good in presentation, so he's going to talk about blasts Thursday. So Thursday is our guest lecture series. After January first week, we start the Wednesday lecture series as well. Wednesday lecture series will be on buildings. So we have Tuesday, we have the building lecture series. Wednesday we'll have in the new year, from first or second week of new year, we start the highway, the highway, tunneling, water reading structures, all kinds of other structures, except buildings, will be covered in that lecture series. And then Thursday we'll have, every Thursday we'll have 1 hour, 1.5 hour lecture. But one of the Thursdays, generally the third or last Thursday of each month, will be a longer lecture, like 2-hour lecture with a more eminent person. So you'll have educational activities every Tuesday, Wednesday, Thursday. So coming Thursday, please expect the lecture on blasts. And coming Tuesday, I'll teach you how to handle design at the preliminary design stage for a medium rise building. First, I'll take the example of a building having less than 10 floors. Then I will take an example of a building having more than 15 floors. Is that okay, Manjula?
Yes, then shall we wind up this note and...
Yeah, so we take the questions because I did not explain anything specific to take questions. But if you have any questions in the chat channel, Manjula, if there are good interesting questions, we can look at the chat channel and note down those questions so that we can answer those the next time.
Right. We have base camp also in the Civil Engineering Sectional Committee. Those who are the members of the IESL can write their questions in the base camp.
Yeah,
and we'll open a new topic on this subject.
Yeah, okay, that's fine. That's fine.
Then we have sectional committee meeting at 7. I invite Engineer Sapumal Rupasinghe to report the vote of thanks today.
Thank you, sir. Good evening to all of you. I'm Sapumal Rupasinghe, coordinator for the public presentation subcommittee of Civil Engineering Sectional Committee. On behalf of the Engineering Sectional Committee, I'd like to take this opportunity to express our gratitude to Professor NTR Jayasinghe for his dedicating your valuable time to share your knowledge and experience in designs of medium-rise buildings and tall buildings. Also, we are grateful for your initiative on this webinar series about the design of high-rise buildings. Also, all the members of Civil Engineering Sectional Committee for support and guidance given to organize this webinar series. And I'd like to express my gratitude to staff of IESL for the technical support and publicity given within a very short period of time. Finally, I'd like to thank all the participants for attending the first session of this webinar series with a very short notice. We would like to invite all of you to attend the next session of this lecture series, as well as the presentations and events organized by Civil Engineering Section. Please keep in touch with IESL and the Civil Engineering Section Committee. Thank you again, and we wish you to see you in the next session. Good night.